The universe is a symphony of motion. From a falling apple to a satellite orbiting Earth, everything is in a constant dance of pushes and pulls. But why do some things move fast while others move slowly? Why do some stop and others keep going? The answer lies in a deceptively simple equation that changed everything. F equals ma. To truly understand the genius of F equals ma, we have to rewind to a world that saw things very differently. For centuries, the prevailing view came from the ancient Greek philosopher Aristotle. He believed that objects had a natural place and that a continuous force was needed to keep something in motion. A push was required to keep a cart moving. Otherwise, it would naturally slow down and stop. This seemed to align perfectly with everyday experience. But this view had problems. What happens when you throw a stone? What keeps it going after it leaves your hand? Aristotle's followers proposed invisible forces, and the explanations became increasingly complex. The shift began with Galileo. He conducted clever thought experiments, imagining a frictionless world. He realized that an object in motion would stay in motion, and an object at rest would stay at rest, unless acted upon by an external force. This was a radical idea that directly challenged centuries of thought. It laid the groundwork for the first part of Newton's theory, the law of inertia. A few decades later, along came Sir Isaac Newton, a man of unparalleled genius. In 1687, he published his masterpiece, the Philosophiae Naturalis Principia Mathematica, or Principia. Within its pages, he laid out his 3 laws of motion, with the second law being the most quantitative and powerful. Newton's first law, building on Galileo's work, defined inertia. The second law then gave us the how. It provided the mathematical connection between the forces acting on an object and how that object's motion would change. At its core, Newton's second law says, the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. So if you apply more force, you get more acceleration. If the object has more mass, the same force will produce less acceleration. This relationship is beautifully summarized by F equals ma. It's a simple, elegant recipe. Force equals mass times acceleration. The force is the cause, and the mass and acceleration are the results. So, how do we know this works? Newton's theory was revolutionary because it was predictive and could be tested. One of the most classic classroom experiments to demonstrate F equals ma uses a setup you can replicate at home. By keeping the mass of the cart constant and increasing the hanging weight, the force, you can observe the acceleration increase proportionally. Then, by keeping the hanging weight constant and adding mass to the cart, you'll see the acceleration decrease. The data from these experiments perfectly confirms Newton's prediction. F equals ma isn't just for physics labs. It's the engine behind so much of the world around us. Think about a car. The engine provides the force, and the car's mass determines its acceleration. A lighter sports car with the same engine as a heavy truck will accelerate much faster, or a rocket launch. A rocket's powerful engines create a massive upward force to accelerate its huge mass, overcoming the force of gravity. Even in sports, a soccer player kicking a ball is applying a force. The ball's mass and the force of the kick determine its speed and trajectory. And when you go bowling, you have to apply much more force to that heavy bowling ball to get it to accelerate down the lane than you would to a lighter tennis ball. So, what's the takeaway? For centuries, we believed objects needed a continuous force to move. Then Galileo challenged this by introducing inertia, the idea that objects in motion stay in motion. Isaac Newton turned this concept into a precise mathematical law. F equals ma. The equation explains that an object's acceleration is directly linked to the force you apply and inversely linked to its mass. F equals ma is a fundamental law that explains everything from a simple push to the complex mechanics of space exploration. It's the mathematical heartbeat of our physical world. Thank you for joining me on The Light. If you enjoyed this journey into the heart of physics, don't forget to hit that like button and subscribe for more content. Stay curious, and remember, there's always more to discover.